Hey guys, with my greeting, this is Philip from pantechelearning, and I welcome you all for engage your learning experience with pantechelearning anytime, anywhere, and any places. We are always supportive to the students in a technical way. What is our main vision? We are going to help 10 million students to learn the technical knowledge by the easy way. And I welcome you all to today's session of Artificial Intelligence Masterclass. I welcome you once again. So today we are going to discussing about one of the interesting topic in the OpenCV. Normally, the OpenCV package will returning them, many functions for processing on the image. That will be actually, it will be, going to do some amazing things on the image. For example, in this particular session, we are going to discussing about the, color-based object detection. So normally the computer can detect the color and computer can change the color and computer can, using the different colors to finding the object that can be possible. How? Actually, we having here, two different concepts like, channels for the colors like that. So normally the grayscale image having the single color and colored image having the three different channels like, P, G, R. So these all are the like, color channels. Okay, color channels. We are going to processing on the colors channels. Then only it can be possible to, detecting the object. That is the basic concepts for these particular session. Okay, so without delay, I am going to discussing about the object track based on the color. So that is also one of the interesting topic, and it will be more interesting to tracking the object by using the color. That is also little amazing, right? So without delay, I am going to discussing about that. How it can be possible actually, object track based on the color. That means we have to processing on the image and we have to creating some certain function to detecting the image with the help of detecting the color for that particular image to tracking the objects. Okay, so these are the things we are going to discuss. So what are the procedures we are going to follow today? Okay, so are you guys are excited? If you guys are excited, means don't forget to hit the like button as well as the please mention in the comment box. Okay, right. So without delay, what about the task today? So what are the things we are going to do? So about this task, we are going to make some basic object detector by using the colors in OpenCV. So in this particular task is the basic object detector by using the color. So that is the reason I mentioned here. So we are going to make the basic object detector by color using the OpenCV Python, because OpenCV will giving the many functions for processing on the image or different kind of the things it will be too. Okay, that is nothing but little bit pretty actually. Okay, right. So here we will create this using the image processing technique is called as the color detection as well as the segmentation. We are going to follow the two different things based on the color detection and based on the image segmentation that can be possible. So what is the meaning of the color detection and what is the meaning of the image segmentation? We will I will be explained and we will be learn in the next slide. So normally OpenCV has some built-in function to perform the color detection as well as the image segmentation process. So what is that exactly? This kind of the things. What is the meaning of color detection and what is the meaning of the segmentation process? That we are going to discuss. Okay, right. So first of all, what is color detection exactly? So what is color detection exactly in this? Color detection is a technique of detecting the any color in given range of HSV. In given range of HSV that can be possible. That like hue, saturation value. Okay, so based on this value, it can making the color for lower and upper like that. So once I'm going to explain it the code, then only you can understand about this. Normally in general formation, I will give the some value for the colors. And what about your understanding about the color? So these are the things we have to know, right? For example, 0 is nothing but the black. 1 is nothing but the white. Or 0 is nothing but the black and 255 is nothing but the white. So these are the things already we know in the computer vision concepts. Am I right? So what is the in-between colors like, for example, 120 is related to the grayscale image. And what about the remaining color? These are the things I will be explaining. Just open paint here. Okay, just open paint here. I will show the example for the colors range. Okay, colors range. You can just go to the edit colors. Just a minute. Now you can see here they are mentioning the RGB value here. Okay, they are mentioning the RGB value. If I mention here 255 and remaining will be 0. So what is the color in game here? So here is the red. So now I am going to clear and I mentioned here 255. What is the color range? 255 color range. What is the color range? Because I given a color for green 255, that is nothing but green color it displays. You can see here now. And what about these here? Like for example, 255 for blue. Okay, sorry, 255. So what is the range of the color? What is the range of the color? That is nothing but blue. If I change the value here all 0 in the sense, what is the value here? That is black. If I change the value all the 255, the range between 255, that is the, the colors value, the pixel intensity value here. So if I change the value all the 2 to 55 in the sense, what is the color range? That is why it is converted like this. For example, if I change the value 255 for red, 255 for red, and I change the color here like 0 and remaining blue will be 255. Okay, 255. So what is the range? Here is the 0. So what is the color? It is the mixed color of red and blue. If I change the value here like 0 and for green, what is the color will come? It is related to yellow. So that can be possible. This is the way the color will be mixed in the range of the 0 to 255. For example, 125. Okay, 125 I mentioned for all the RGB. You can see the color difference. You can see the color difference. Sorry. Okay, you can see the color difference. Of course, you can see the color difference. That is related to the gray. Because of this is, mid value. So this is nothing but a one single channel of the color. Okay, so this is the way you can fixing the color for detecting the, colors like that. For example, once you are going to entering the coding, so we need to fixing the value like, H, U, E. So that means HSV value, we have to fix it. So hue saturation value. That saturation value based on the arrays, based on the numbers, based on the pixel values, then only it will be detecting the color. So that is the reason I'm saying here. Okay, that is the reason I'm saying here. For example, here I mentioned 20. Just an example. Here I mentioned 20 and here I mentioned 50. Yeah, 30. Okay, sorry, 30. Okay. Then here I mentioned 255. So what is the color will come? It is a dark blue color will come. If I change the value here 125, 126, it is a dark blue. Like that, based on the pixels values, it will be returning the output like this. Okay, right. So this is the way the color concept will be there. So that means in between 0 to 255, it can making the different colors that can be possible. That's why, for example, initially 255, 0, 0, like that in the sense it is the, for example, it is like for this region RGB. If I mention HSV in the sense that value will be differ. The value will be differ. So like that you can create the color. Like that, you can create the color. Hope you guys are understood about the coloring concept of the computer vision. The computer can taking the values only because the computer can't understand the color exactly because you know about the experience that the color. Because of your experience, you can't recognize the color. That can be possible. That can be possible because of your past experience. In the same way, we need to intimate and we need to giving the value for the color. Then only the computer can understand easily. For red, for blue, for yellow, for black, for like pink, for orange. That can be possible fixing the value for the color. That means with the help of the three different channels. Okay, right. So this is the basic concept just for the understanding I'm saying here. Just for the understanding by using the paint and just for the understanding I'm discussing about this. So this is nothing but the with the help of this particular range we can create the color and we can detect the color in machine. Okay, right. So this is the color detection. What about the image segmentation? So image segmentation is the process of partitioning the digital images. That means we are going to partitioning the pixels of each and every each and every pixels in the image and labeling the every pixels. We are going to partitioning the pixel and labeling the every pixels. So based on the pixel we can make it the label. We can make it the label. Okay, so then where each pixel is having the same label, then share the certain characteristics. That is nothing but the image segmentation. So we are going to follow the two different procedure. For once you are going to track the object by using the color, in the sense we need a segmentation process. What is the segmentation process? We are going to extract and segmenting the, like the based on the pixels, based on the labeling, pixels, labeling the pixels values, then only it can be extracting the object and tracking the object. It can be possible with the help of the pixel range of the color. Then only we can detect and we can tracking the object inside the image. So that is the reason we need to find the detecting the color, as well as we need to find and we need to do the image segmentation process. So we need the two different process, color detection as well as the image segmentation. So based on the color detection, we can segmenting the image, we can segmenting the object inside the image. So that is the reason we are going to follow the two different procedure. That's why I mentioned here. It is partitioning the object inside the image based on the pixels value. And we can create the label for based on the pixels values. Then it will be, finding the characteristics of the same pixels and same label of the pixel. That can be make it. That means segmentation means we are going to, making the group for the that particular, characteristics based on the characteristics. That is nothing but the segmentation. Already you knew this, right? So what are all the steps we are going to follow this particular task? Very important. First, initially we are going to every task we need to importing the necessary libraries, import the necessary libraries and reading the image. That is the first process. The second one, detecting the color is very important. Why? Because we are going to detecting color, because we are going to tracking the object by using the color detection. Without color detection, our task is not complete. Right? This is the basic object detector by using the coloring range. So that is the reason we are going to detecting the color from the input image and creating the mask for extracting the object from the image. Then removing the unnecessary noises from the image. That means unwanted noises will be there, for example. Once you are going to detecting the object, in the sense we need the exact necessary object only we need. That time some unwanted noises will be there. That unwanted noises we have to remove that. Then only it will be returning the exact output for our particular task. Hope you guys are understood about this. Okay, right. So removing the unnecessary noise from the mask. Then applying the mask to the image. Why we are going to applying the mask? Because of it will be help to extract and highlighting the image and highlighting the object of the image based on the color. Okay, then draw the boundary of the detected object. Draw the boundary of the detected object. Okay, right. So now I am going to explain one by one. After that, I will be explain the coding. Then only you can understand easily. First, we have to import the necessary package and initializing the camera or initializing the input. Okay, initializing the input or initializing the camera. So here we need to import the CV2 module. CV2 module as well as the NumPy sometimes is needed for creating the arrays for the colors. Okay, so we are going to creating one particular array that will be mentioned and that will be written like a different colors for detecting the object. For example, lower boundary and upper boundary like that for the different colors. Okay, right. So imported OpenCV module by call it as CV2. So import CV2 we have to mention. Then how to loading the image with the help of cv2.imread. That particular function will help to loading the image for our input. Okay, right. Then cv2.imshow, it is the function to showing the image which is loaded. Okay, which is loaded. Then wait case of 0. So that means the image window will be opened until any keys is pressed. Okay, so it is the holding the window. It is holding the window until you are going to click any buttons in in your laptop. So the first one, how to loading the image with the help of cv2.imread, that will be help to loading the input image. What about the second thing? So we need to, how to show the image with the help of the CV2 dot. I am sure that particular function will show the image. Then what about the wait keys? So that means the image windows will be opened until any key is pressed. Okay, hope you guys are understood about this. Hope you guys are understood about this. If you guys are really like the session and really like the presentation means, please mention in the comment box as well. And don't forget to hit the like button and share your opinion to philip.bedit@pantechmail.com. That is our, that is my mail ID. So if you have any queries and any suggestions, you can just send them one single mail ID, mail to this mail ID, like, pantech, philip.pedit@pantechmail.com. Okay. So if you guys are really like the session means, please don't forget to, hit the like button and please comment me in comment box as well. Okay. Right. Now, the second things, detect the color from the input image and create the mask. Detect the color from the input image and creating the mask. So what is the purpose of that exactly? So detect the green object in this image as well as the yellow object in this image. That can be possible. Whatever it is, you want to create, like detecting the green color, detecting the blue color, or detecting the yellow color. That can be possible to create one particular, object for that particular color with the help of the number. And here, detecting the green color object inside the image, and then it will be detecting the yellow object also. Okay, so here the OpenCV reads the frame as a PGR. Okay, normally once you are going to loading the image, OpenCV always taking as the image in the format of PGR, not in RGB. The OpenCV taking like PGR. So, but it detected the any colors. But to detect the any colors, first we have to convert, PGR into HSV color space with the help of CV2 dot convert color function. How to convert the color with the help of CV2 dot convert color function. So here we can detecting the green object as well as the yellow object. Okay, we can create one particular color range for the green as well as the yellow. OpenCV normally reads the frame in the format of the PGR, but we are expecting the HSV, so we need to convert. But we need to convert PGR into HSV. How it can be possible? With the help of CV2 dot convert color. CV2 dot convert color, that will be help to converting the PGR into HSV. Okay, right. So that function will help to do that because we need to converting the HSV color space, that will be help to detecting the color in a easier way. Okay, right. So why HSV? Maybe that you are asking the question to me. Why HSV? HSV is a color space is useful when we are working with the color information. If you want to working with the color information, in the sense you have to convert the HSV. That will be more helpful to getting the information about the color. Okay, right. So what is the state for HSV? So HSV stands for hue saturation value. So what is the meaning of hue? So hues are modeled as an angular dimensions that encode with the color information. Hue are modeled as an angular dimensions that encoded with the color information. So what about the saturation? So saturation is encoded with the intensity of the color. Intensity range of the color. Then what is the value? Value is represent the amount to which that the respecting the color is mixed with the black. The value is represent the amount to which that respective the color is mixed with the black. Okay, that is nothing. It is a stands for like that. Hue is like modeled as an angular dimension with the encoded color information. And what about the saturation? Saturation is encoded with the intensity of the color. The value is represent the amount to which that respective color is mixed with the black. Okay, this is nothing but the HSV. Actually, it will be more helpful to detecting the colors. Okay, right. What about the third step? Removing the unnecessary noises from the mask. Removing the unnecessary noises from the mask. Because we need not any unnecessary noises here. because we need expecting expected object for the by using the color detection. So we can see that there is a lots of unnecessary noises here. We can see that. Okay, I will show the output for that particular things. Okay, right. So we have to remove it for the better understanding, better result. So that we need to remove the unwanted noises or unnecessary noises from the masked image. Okay, then by using the how we can do that to removing the unnecessary noises. Here we are using the morphological operation. So what is the meaning of the morphological operation? With the help of the dilation and erosion, the morphological can be processed. So what is the meaning of the dilation? What is the meaning of the erosion? So that is the question, right? So we having here certain information I will tell you. But if you want to know about this in the sense, we shared the video already for like that particular process. If you want to need to know about more about in the sense, you have to watch the video. Okay, watch the video in image processing masterclass. Okay, right. So normally we were discussing about this particular topic, morphological operation. We were discussing about in image processing class. Okay, so we were discussing about that actually in image processing class. So I will tell you, morphological operation is processed with the help of the erosion and dilation. So what is the meaning of the dilation? What is the meaning of the erosion? So dilation is nothing but improving the intensity of the image or object. What about the erosion? It is going to reducing the intensity of the pixel in the image. That means dilation and erosion. Dilation will help to increasing the intensity of the image. That will be help to improving the pixel intensity of the image. That will be like clear object. And what about the dilation or erosion? So erosion is nothing but reducing the intensity of the image. With the help of the the pixels are going to increase in the dilation. The pixels are reducing in the erosion. That's it. That means, for example, it will be help to returning the cleared object. We can find it easy. So that is the reason we are going to use the morphological operation. So once you are going to using the morphological operation, morphological open and morphological closed. Okay, that means erosion followed by the dilation is nothing but the morphological open. What about the morphological close? Like that is nothing but dilation followed by the erosion. Okay, dilation followed by the erosion. So that means what is the purpose here exactly? That is very important, right? Yeah. So for the object detection, we need a clear image. So that is the reason we are going to use the morphological open and morphological close. So once you are going to using the morphological open function and morphological close function, we need kernels. How to create that? So with the help of numpy dot ones of the kernel size 7 by 7 or 5 by 5 or 3 by 3, you can use it. Here I am using the 7 by 7 in the format of integer format. Then create the 5 by 5 8-bit integer matrices. Okay, so here the CV2 dot morphological close is removing the unnecessary black noises from the image. Okay, in the white region, and morphological open is removes the white noises from the black image, black region of the mask. That means once you are going to mask the image, that will be converted into the binary image. That means black and white. So sometimes the object will be white and background will be black. Sometimes the object will be black and background will be white. So once it is, we are going to use the morphological close and morphological open. The morphological close will help to removing the unnecessary black noises from the white region. And what about the open? It removes with white noises from the black region of the mask. That will be help to creating the clear object detection. So it will be more helpful to detecting the object in a easier way. Okay, so that is why we are going to removing the unnecessary noises from the image. Okay, right. Then apply the mask on the image. Why we are going to do that this particular project? Task, because we are going to detect the particular object in the image by using the color. So once you are going to detecting the color and we are going to making the masking for that particular color in the sense that can be possible to detect that by using the mask. That means we will segment We will segment the green region or yellow region from the image, because we created already the range of the color for yellow and already created the range for color of the green region. So we masked that particular color. How to segment? That means we are going to use the bitwise AND. Okay, so this is a different concept for masking the image. For masking the image, once you are going to target one particular object in the sense, but with the help of this particular bitwise AND will help to extracting the object from the image. How to do that? So with the help of CV2 dot bitwise AND, it applies the mask on the frame. It applies the mask on the frame in that, in only that the region where the mask is the true means it will be white. Why? Because normally this will be help to returning the finded on the detected object. For example, what is our target? Yellow color object. Okay, once you are going to use that particular bitwise AND, it will be help to detecting that particular yellow color and mask that. It will be returning the format of the white format of that particular object, and it will be help to detect that with the help of the fine contours. It will be more helpful for detecting the fine contours. Fine contours in the sense what? It will be help to detecting the particular object of the outline. Okay, so this is the applying the mask on the image. So what is the next thing? Draw a boundaries of the detected object. How it can be? We will draw the boundaries over the detected region. How we can detect it? With the help of the fine contours. What is the meaning of that particular contours actually? So contours is nothing but will help to detecting that particular object inside the image with the help of the edges detection. With the help of the edges detection. How it can be possible? So because of image processing having the different functions. Once you are going to thrashing the images, that means we are going to converting the binary images, the fine contours will be very easy. The binary images will extracting the foreground from the background. So that is nothing but the threshold process. So image processing having the several functions for detecting the object. For example, edge detection will be there, threshold process will be there, find contours will be there. So that will be help to finding the object inside the image. Once you are going to using the find contours, once you finding the contours of the particular image. So what is the process of the contours? Actually, so process is nothing but detecting the object based on the outline of the object by using the threshold image or binary image. Based on the binary image, it will be finding contours. It will be finding the contours. After finding the contours, it will be going to draw the detected contours. So the find contours will returning the detected object based on the color. Okay, so CV2 dot find contours find all the possible continuous point along with the boundary. And what is the draw contours? The draw contours will once the contours found, we need to draw the outline of the contours. That's it. So contours, find contours will returning the detected object based on the threshold or binary image. Because the threshold and binary image will returning the black and white image. For example, it will be help to extracting the foreground from the background. So what is the meaning of foreground? Is nothing but the object. Background is the black and white. Based on the colors, it will be detected. So once you are going to using the find contours and draw contours, it will be highlighting the object. That's it. And detecting the object and highlighting the object based on the draw contours. Okay, I will show that. Then only you can understand about this particular concept in a easier way. Okay, right. So that's it. Without delay, I am going to explain about the coding here. Okay, explain about the coding here. Just enter, that particular concept. I'm going to explaining about that. Okay, I'm going to explaining about that. Okay, right. So here I'm going to use one certain process to detecting the object in a few 25 lines of the code. That's it. Okay, it is very easier to detecting the object based on the color. So first we need to importing the two different libraries. First one CV2 and second one numpy. So numpy will help to creating that particular array for the different colors. Okay, array for the different colors based on the PG or that RGB range. It will be detecting the colors like that. Okay, right. So now without delay, I'm going to explaining about the coding. Right. First, how to loading the image with the help of cv2.imread. So already I sent to you. All right. So cv2.imread will help to loading the input image. Okay. Then defining the kernel size for what purpose? Morphological operation. Morphological open and morphological close is we need the kernel size of the object. So kernel size like np.1 7 by 7 in the data type is a integer data type. So defining the kernel size here. After that, converting the color PGR into the HSV. PGR into HSV. That means we need to converting the color space PGR into the HSV. Why? Because normally the image will be taking the OpenCV will taking the images as a PGR format. So we need to converting the HSV for detecting the color in a easier way. Because HSV will help to having the more information about the color. So that is the reason it will be detecting the color in a easier way. So the HSV is equal to, so this is the user defined variable. We are going to storing the value to this particular variable, HSV variable. So we are going to converting the color with the help of CVT color. So that is nothing but the convert color. So CV2 dot convert color, that particular input image. So which we created before. Okay. Then you can see this convert color PGR into HSV. So PGR to HSV. So this will be converted the color. Now we are going to creating the lower boundary and upper boundary for the yellow color, for the green color. Okay, you can create the different colors, for example black, white. Okay, I will show the example after finishing this. Okay, I will show the example after finishing this. So now we are going to creating the boundaries of the color for yellow, for green. So this is for the green color. This is for the green color. This is the lower boundary of the green color. So that means you can see here the 50 and 20, 20. This is the range between the three different color channel. This is the lower color of the green. Lower color of the green. Okay. Then what is the upper boundaries of the color? So in numpy dot array of 100, 255 and 255. Okay, you can check it in now. Edit color space in a paint. You can see that. You can see that in a easier way. Okay, right. So this is for the green and this is for the yellow action. You can see here. This is for the yellow. So lower boundary for the yellow and lower boundary for the higher upper boundary for the yellow. So this is the range between the yellow. This is the range between the higher boundaries of upper boundaries of the yellow. So this is the range for that. Okay, this is the range for that. Actually, this is the HSV color space. HSV color space. Once you change that particular HSV, it will be returning the low green and high green and low yellow and high yellow. It will be returned. You can check it and you can paste this value to there and it will be returning the output. Okay, returning the color. Okay, now we are going to finding the color with the boundaries. This is nothing but masked creation. Okay, now we are going to creating the mask for the colors, for yellow, for white. For yellow, for green. Okay, so find the color within the boundary. Find the color within the boundary. This is the ranges for the yellow, for lower and upper, for the green and for yellow here. Okay, right. So now I'm going to command this one. Now I'm going to detecting the green color first. Okay, green color or yellow color, whatever it is. Okay, now we are going to detecting the color based on the green color. Okay, for yellow in the sense you can uncommand this one and it will be returning the output like that. So mask CV2 in the range of HSV format, then range between the lower boundary and upper boundary. Okay, lower boundary and upper boundary. Maybe that you get little confused, right? So just open the paint. Okay, just open the paint. You can go to the edit color. You can go to the edit color and change the HSV space and enter the value here. Okay, and just a minute. Okay, and enter the value here, like this value and this value. It will be returning the like green color based on that. Because of that, the HSV color is completely different. So this is the range for the HSV color space. Okay, right. So in a range for the HSV image, and this is the lower boundary for the green and upper boundary for the green, because we are going to detect in the green color first. Okay, then removing after that, after creating the mask, we need to removing the unnecessary noises from the mask. So we created the mask here. Now we are going to removing the unnecessary noises from the that particular mask. That means we are going to removing the unwanted black in the white space and unwanted white in the black space. So with the help of open and close. With the help of morphological open and close. So already I said to you the morphological open and morphological close, the basic operation dilation and erosion. So dilation is nothing but improving the pixel intensities and improving the pixel value of that particular image. That is nothing but enhancing the image. That is dilation. What about the erosion? That is decreasing the pixel intensity of the image. That is decreasing the image. That means reducing the highlight of that particular image. That's it. So here the mask, what is the process actually exactly in that morphological open and morphological close? So already I said to you, for close, removing the black noises from the white region, that is close. Removing the white noises from the black region, that is open. Okay, right. So now you can see here. So we are removing the unwanted noises from the black region as well as the white region. Okay, so with the help of this particular process, morphological X and morphological close, kernel size we have to pass here, and masked images we are going to pass here. Okay, right. So after that, you are going to like segmenting the detected region, segmented the detected region with the help of like bitwise and. With the help of the bitwise and, this is also nothing but a masked process or image segmentation process. Already I said to you, right, two different processes we followed. One thing is color detection, the second thing is the image segmentation. So the segmented image CV2 dot bitwise and. Okay, bitwise and for the image, original image, and you are going to pass the masked image. This will be helped to segment at the that the particular image. Once the object is detected, we are going to find in the contours of that particular mask the image. Okay, this is the the image is segmented with the help of the binary image. Okay, this is displays the binary image only. Now we are going to find the contours from the mask, this particular segmented image. So we are going to create the two different variables, because of the find contours is expecting the two different variable. Okay, the hierarchy and contours. This is a user defined variable. So CV2 dot find contours. This function will finding the contours inside the image. Our targeted object we are going to find with the help of the find contours. So this is the masked image. Okay, so we are going to passing the mask image. Then CV2 dot retrieval extern. So this will be external. So this will be help to returning and retrieval all the possible contours inside the image. What is our target exactly? So here that is the green target. Okay. So this particular function retrieve all the possible contours inside the image. Then this is the algorithm to returning the contours, that is objects. Then now we are going to draw the contours. Okay, draw the contours. So that is output is equal to CV2 dot contours. This will be help to once you finding the contours, it will be draw the outline of the contour. So with the help of the draw contours for the original image, then detected found contours. Then this is the contour index. That means -1 in the sense it will be displays all the possible contours for our target. And this is the range. This is a color range, like red color. Then this is like, thickness of that particular outline. Okay. So after that, CV2 dot IM show will help to showing the image output for this. So this will be returning the possible highlighted object contours. Okay. Then finally it will be showing the result. Okay. So what is the image I'm going to use? The first image, just a minute, guys. I'm going to open that particular folder, then only you can understand in an easier way. Okay, right. So this is the folder and multicolor. Where is that actually? Yeah, multicolor detection. I'm going to use first this image. Okay, this image, this particular image, it has the two different color for green and yellow. Okay, by using that particular code, it will be and returning detecting the green color. That is nothing but the object tracking. Hope you guys are understood about this. Okay, so what is the image name here? The image dot jpg. Okay, the image dot jpg. Now I'm going to copy and paste here, like yeah. Now I'm going to run this. You can see the output for this. Okay. Yeah, this is the output. This is the output. Apart from this images, all the green region, all the green object is detected. So this is nothing but the draw contours. This is what the all the possible contours is drawn with the help of the draw contours. So this is the output. You can see the image here. This is the masked image. This is the masked image. That means unwanted noise is removed. The cleared image. So target image, what is the target here? Actually, that is like green. So green image, that is the white is the targeted object. Black is the untargeted object. So it will be detected like this. This is the masked image. Okay. Then you can see the output. This is a segmented. Object is segmented. Object is segmented. This is a necessary object. You can see this now. You can see this. This is a segmented object. Remaining color will be like unwanted object of our particular target because we are using the green channel, green color. Okay, right. So this is a segmented image. Then finally the output will be like just a minute. You can see the output. This is the green segmentation object based on the color. Based on the green color, we can segmenting the object. Now I am going to use the yellow color here. Okay, how to do that? Just green is commented and I will comment. Then now uncomment the yellow here. Okay, now you can see the output for this. One more time I will run this. You can see the output for yellow. Now the yellow object is detected. Now the yellow object is detected. Remaining will be the unwanted object because of our target is the yellow object based on the color. Am I right? Hope you guys are understood about this. If you guys are really understood means please mention in the comment box yes fellow. Please mention in the comment box yes fellow. Okay, so this is here segmented image for the yellow image, yellow object, segmented image. Then you can see the white will be the targeted object by using the yellow color. Right? So this is the way it will be working. This is the basic object detection, object tracking. Okay. So I'm going to use the different images as well. Okay, different images. What is the image? Yeah, different images in the sense. I'm going to open that particular folder and see that I'm going to use the image2.jpg. So what is the image format and go to the property. What is the extension? JPEG. So I'm going to use the image2 dot image2 dot. What is the extension of this? JPEG. Okay. So you can see that no. So I'm going to using the different images here. Okay, I'm going to using the different images here. Now we can see the output here. Like segmented image only for yellow because of our target is the yellow object. And this is the white region is the targeted object. That is like masked image. And this is the segmented object. Then finally it will be detected by using the draw contour. Draw contours. You can see the output, right? So this is for like that particular things. Okay. I'm going to use the different images that is like rows. That is also one file. So that is the different images here. That is JPG, and I'm going to use the green space or yellow space. I'm going to use the green space. Okay, yeah, green color space. So on command for the green color space. Now I'm going to run this. So based on the two different color, you can create the different colors. You can see here. You can see here. This is like the output detected green object. Detected green object. And this is like segmented images for the green, and this is for the segmented images. That is the white space is nothing but the detected object. Hope you guys are understood. Hope you guys are understood. I hope you guys are understood about this. Okay, for the yellow, how it will be detected? You can see that. For the yellow, I command the green color space and command the yellow. So what is the output we'll see? Sorry. For green, it will, for yellow, it will be detected. For yellow, it will be detected. Like this only, it will be detected. You can see this image, segmented image. Yeah, yellow will be there, yellow will be there, yellow will be there. And this is, targeted white space object, like masked image. Okay. Yeah, hope you guys are understood about this. Okay, this is the way you can, this is the way you can start tracking the object by using the color. Okay, one more thing, I will show the output for the multicolor detection in a real time. So already we were discussing about this particular concept in image processing masterclass actually. Okay, see here, set the range of the yellow red color. So this is the, range of the red color. And you can see here range of the green color. And you can see here range of the blue color. And you can see here the dilation process and erosion process for masking the image and segmenting image. This is nothing but the segmenting the color. This is nothing but the segmenting the color. And finally you are going to finding the contours. Okay, finding the contours, and finally draw the the rectangle box is detected. Okay, now I'm going to run this. You can see the output for this. Now it is going to accessing the camera. So behind the screen, the green will be there actually. The green will be there and blue color will be there. Because I'm going to use the three different color, red, blue, green. Okay, you can create white, yellow, and blue, black, whatever it is you can create. Okay, you can create, and you can see this is the blue color and this is the green color and this is the yellow color. Like this only you can create and detecting the multicolors in a real time. Okay, so this concept I implemented to the object tracking as well. Okay, this concept is into today like object tracking concepts. I created for three colors. You can also create it for the range of different colors, Okay, right? So this is nothing but real time multicolor detection. So this concept, this basic concept, I implemented to this particular object tracking. Okay, so just follow this procedure for the internship user. I will share the for the internship user, I will share this particular multicolor detection code also. You can try it yourself. Okay, right. So that's it, guys. This is what this is all about object tracking by the color detection. Okay, right. Hope you guys are understood about it. If you guys are really understood, means don't forget to hit the like button as well as say please mention in the comment box as well. Yeah. So without delay, I'm going to entering my time. Without delay, I'm going to entering my time. Every day I mention the one particular motivational quotes to you. The first one. Okay. So here, today's friendly reminder. Today's friendly reminder. Always end your day with the positive thoughts. Always end your day with the positive thoughts. No matter how hard today was. No matter how hard today was. And just remember, tomorrow is the full of better possibility. Every morning is a new beginning. Every morning is a new opportunity. Okay. So always end your day with the positive thoughts. Always end your day with the positive thoughts, no matter how hard today was. And just remember, Tomorrow is a full of better possibilities. That means the new opportunities will come. You can make your day in a positive way and make yourself in a happier way. Be smile always. Make yourself make yourself happy and end with your day in a positive thoughts. And tomorrow it will be like, every tomorrow's every morning is a better opportunity and best opportunity for your positive thoughts to make your day. Okay? It's make your day in a positive way. Make your day in a positive way. So thank you so much, guys. Thank you so much. Explore your knowledge with us. We are always here for you to support you in a technical way. Okay? Explore your knowledge with us anytime, anywhere, and any places. We are always supporting you for that technical way, and we are always here for you to support you in a technical way. Thank you so much and enjoy your evening. Thank you so much. Bye bye. We'll see you. We'll see you in the next day class with a different topic. Thank you so much. Bye bye.